Hello everyone, we have introduced the MOSFET in Lecture 9. In lectures from 24 to 26, we have discussed how to constitute the basic gate circuits of the digital system by using MOSFETs. We all know that for a MOSFET, there may be three conditions between D and S: the open circuit, the resistor, and the dependent current source. For a real circuit, which condition does it work in? We will give the answer in this lecture. Before the analysis of a specific circuit, we need to review the three different kinds of the working areas of a MOSFET and their corresponding restricted conditions. Let's analyze the cutoff region first. That is an open circuit between D and S. At this time, the condition is UGS is smaller than UT. When UGS is larger than UT, it's conductive between D and S. We can regard UDS and IDS as a two-terminal network. The previous simulation shows that the relationship between the voltage and the current is like this. We can regard this part as a current source. According to the previous analysis, we know it is a nonlinear voltage-controlled current source. Did you find out? Only when UDS is relatively large, it is a nonlinear voltage-controlled current source. That is to say, the condition for regarding it as a voltage-controlled current source is UDS is greater than UGS minus UT. In this case, the value of the current source is K times UGS minus UT squared over 2. So it is nonlinear. It is a third part when UGS is greater than UT and UDS is relatively small. It is a variable resistance. But because the variable range of the resistance is small, we can regard it as an unchanged resistor. So the third section is to regard it as R-on. At this time, UDS should be relatively small. That is, UDS is smaller than UGS minus UT. Next, we will use examples to illustrate how to judge the working region of the MOSFET by using the suppose verify method. Please look at this circuit. UGS is equal to 5 volts. UT equals 1 volt. It must be greater than 1 volt. So D and S is conductive. Next, we make some assumptions. We first assume that it is a dependent source between D and S. It is like this. The parameter of the voltage-controlled current source is 0.5 times 5 minus 1 squared over 2 milliampere. This is the voltage UDS. According to the KVL, UDS equals minus 0.5 times 5 minus 1 squared over 2 times 9 plus 5. In which the milliampere is cancelled by the kilo ohms. It equals minus 31 volts. Let's verify it. When UDS is greater than UGS minus UT, it is true. Here it is minus 31. It is 5 minus 1. So it is false. Our assumption is false. Secondly, we assume that it is a resistor. Because R-on equals 1k ohms, so it is 1k ohm. This is UDS. Obviously, it is a voltage divider. UDS equals 0.5 volts. It need to be UDS is smaller than UGS minus UT. It is 0.5. It is 5 minus 1. It is true. This answered the problem we asked in teaching the gate circuits. That is, when the voltage of source is 5 volts, the pull-up resistance is large enough, the input signal is changed from 0 to 5 volts. When the input signal is 5 volt, it can be regarded as R-on between D and S. Here we offered the explanation for the above statement. Next, let's look at the case when UGS changed. All other parameters remain the same. What does happen when UGS is changed to 1.3 volt? First, we assume that it is a resistor. The same as the previous calculations, UDS equals 0.5 volt. Only when UDS is relatively small, it is a resistor. So it needs to be UDS is smaller than UGS minus UT. Here it is 0.5. It is 1.3 minus 1 equals 0.3. So our assumption is false. Next, we assume that it is a nonlinear voltage controlled current source. The controlled variable is 0.5 times 1.3 minus 1 square over 2 milliampere. Similar to the previous analysis, UDS is equal to minus 0.5 times 1.3 minus 1 square over 2 times 9 plus 5. It is 4.8 volt. In this region, its condition is UDS needs to be relatively large. So UDS is greater than UGS minus UT. So here is 4.5. It is 1.3 minus 1 equals 0.3. So it is true. In lecture 45, we will use a similar condition to realize a small signal amplifier. You see, in this page and the previous one, the topology of the circuits are completely the same. The only difference is the changed UGS, which makes the MOSFET presenting different properties between D and S. By using the suppose verified method, we can judge which region does the MOSFET work.